Good afternoon, my name is Madaline Asher, and my topic for material selection was natural fiber composites. And on the left, I included a little infographic about the different types of fibers. For example, like you can get bast fibers, leaf fibers, seed, and other fibers, and then primary and secondary fibers that include flax, hemp, straw, cotton, woods, and bamboos. For the research study, the paper that I read was titled Natural Fiber Composites, Comprehensive Ashby-Type Materials Selection Charts. This was written by Darshil Shah, and it was taken from Materials and Design, Volume 62, on October 2014, pages 21 through 31, and the scope of the paper was about selecting natural fiber composites in the design and development processes. The key question addressed by the author was why natural fiber composites are not utilized as much as synthetic materials, and how to increase proper utilization. On the right, I included a picture of a car door that was made out of hemp and polyethylene composite, and this is just one example of the natural fiber composites being used in the automotive industry currently. For the methodology, the author used Ashby plots, and they were created for a few different considerations about the fibers, such as the plant extraction location, the composites, and the fiber directions. Charts were used to compare the natural fibers to typical synthetic materials. For example, on the right, I included a side-by-side comparison of the Ashby charts for typical engineering materials and natural materials. The indices that were used were tensile strength, Young's modulus, and then the specific tensile strength. And the materials and processes surveyed were the natural fibers, the fiber direction, the soft tissues, the mineralized tissues, wood, and wood-like materials. Materials were also surveyed based on the processes available to them, such as injection molding, compression molding, and a few others. One key result from the study was the author's attempt to close the gap between material data available for design purposes and applications. The author produced charts for design such as stiffness and strength, material weight, cost, and environmental impact. The author suggested that many additional properties must be considered when selecting a natural fiber reinforced plastic, such as fatigue and fiber direction. And on the right, I included one of the Ashby plots created by the author for tensile strength versus fatigue strength for the different directions of the fibers, and the unidirectional fibers had the highest tensile strength and fatigue strength, and the non-woven random fibers had the lowest fatigue strength and tensile strength. Another key result from the study was the consideration of plant fiber reinforced plastics as an alternative to glass fiber reinforced plastics. In many applications, plant fibers are comparable to glass fibers, and the fiber direction plays a huge part into the versatility and the applications. And I included a little chart that is comparing the plant fibers in green to the glass fibers that are in blue. And in many applications, the thermoset composites that included the plant fibers are comparable to the ones that included the glass fibers, but then in quite a few applications they're not comparable either. So that is just one thing to consider whenever you're considering plant fibers as an alternative to glass fibers. So in summary, the key conclusions from the research paper were that plant fibers can and should be considered during design and development, and the lack of consideration currently is due to the lack of empirical data that is readily available. With more data available, such as the Ashby plots that were created, there will be a bigger opportunity to compare plant fibers to the synthetic materials, and the usage of the plant fiber reinforced plastics will grow. The plant fiber reinforced plastics, they might not be a perfect substitution for glass fibers, but depending on the application and the manufacturing processes, that they might be a more environmentally friendly option. My personal critique of the usefulness and the quality of research was that it's very interesting to see how the plant fiber reinforced plastics properties compare to typical engineering materials. Having the direct visualization and data source for these materials will help in the future for designers and developers to compare them to the synthetic materials, and hopefully will incorporate the plant fiber reinforced plastics more into manufacturing. It'll be interesting to see how and if plant fiber reinforced plastics will be incorporated more into automotive and electronics production, due to them being the largest subsection of the plastics industries, that it would be the most important for even small changes to happen in automotive and electronics, because they could add up to a large environmental impact. The compilation of this data will start a shift in the mindset to consider more renewable materials, and the plant fiber reinforced plastics hopefully in the future will be considered more during design and development.